So you would like to see both then? Synthetic division has limited applicability. Limited to a polynomial divided by x minus a, which can be x plus 3. Yes, we can do both, David, thank you. Okay, so this could be x plus 3, it could be x minus 4, it could be x plus 1, anything you want. And I have to identify a. Okay, so let's do that and then we'll come back to the function. So let's look at the long division first. Long division. In the long division, remember, let me write the function one more time. In the long division, I have to make sure that both are in descending order, which they are. Secondly, if there are missing terms from the top, yes, there are missing terms. The degree is 2. The degree 2 is there, but degree 1 is missing. So I have to leave some room for it. And x minus 1. So the first question is x times what is x squared? And the answer is x. But now I have to go back and distribute to both, change the sign, and write below like terms. So x times x is x squared, but I have to write negative x squared. X times negative 1 is negative x, but I have to write positive x. And then I bring down x minus 4. X times what is x? Positive 1. I distribute. 1 times x is x. I change the sign. And 1 times negative 1 is negative 1, and I change the sign. So I box in the remainder. So I write the function as, instead of this, I write the quotient minus the remainder over the divisor. When x approaches infinity, this will approach 0. Therefore, this is the slant asymptote. So I know I'll show the other one in a minute, but I have to make myself a note. Y equals x plus 1, slant asymptote. I have all the summary here so I don't forget anything. And now the synthetic division. The synthetic division is applicable in this case because the denominator is x minus a number. And the number, if you compare these two, then you know the number is 1. At this point, I put a in this little box. I copy the coefficients of the numerator, and if 1 is missing, I have to put 0. 1 is the leading coefficient. 0 is the missing term, and the final term is negative 4 coefficient. The synthetic division is asking us to always copy the first coefficient. Then we proceed multiplying 1 by 1 and writing the answer on top of the line, above the line. 0 plus 1 is 1. I continue with 1 times 1 and I get 1. I write it above the line and I box in the remainder. And now you could say, what is this? Well, here's my answer. If I divide degree 2 by degree 1, this must be the coefficient of degree 1. And this must be the free term, and this must be the remainder. So the same thing, f of x will be x plus 1 and minus 3 over x minus 1. If I have degree 3 over degree 2, then I will have the same thing, leading first term, first coefficient for x, and then the free term, and the same thing. Every time I divide a polynomial that has a degree higher by 1, exactly by 1 higher than the degree in the denominator, I always get a line. So this is the line. So any questions on either one? Okay, so we are ready to graph now. When we graph a function with asymptotes, I have to graph the asymptotes first. So I made a mess here. So 12, 13, 14, 15, 11. Okay. So where is my table? Here's my table. So I see the function has two asymptotes, x equals 1. I didn't mention symmetry, it cannot be symmetric. So, and x plus 1. So I graph x equals 1. And I also have to graph y equals x plus 1. When x is 0, y is 1. When y is 0, x is negative 1. And now I can go to my table, and I see negative 2, 0. I see 0, 4. I see 2, 0. And now I'm ready to read the graph. Always increasing, and between negative infinity and 1 opening up, crossing the x and y, coming from negative infinity close to the slant asymptote, going to positive infinity on the left-hand side of the vertical asymptote. On the other side, it's opening downward. It's coming from negative infinity on the left-hand side of the vertical asymptote, crossing at 2, 0, the x-axis, and going to infinity closer and closer to the slant asymptote. So this is the function x squared minus 4 over x minus 1. And yes, of course, if you'd like to check with the graphing calculator, you have to put in this function. The calculator doesn't know it. You do. So we have, don't forget parentheses around the numerator. X squared minus 4, close the parenthesis, and divide by x minus 1. And don't forget to put x plus 1 as an additional function. And let's say we are using the standard viewing window. Here's the function. And here's the slant asymptote. And the function has to approach it. Has to approach it at negative infinity and has to approach it at positive infinity. And of course there is a vertical asymptote at 1. The range of this function is everything, all the numbers. The domain, anything but 1. So this is a function with a slant asymptote. So the degree of the top must be exactly 1 unit larger, higher than the degree of the denominator. So that a division gives us this line. Any line, a line. So I know we have 15 minutes left, so I will do whatever you want me to do.
Sorry.
Yes.
Synthetic division, I understand how you got the x plus 1 and minus 3, but I don't understand the last term, the over x minus 1, where that came from.
This is the remainder. Very good question. Let me explain this situation with the remainder. So if I divide 9 by 3, I get 3 integers plus remainder 0 over 3. We never do this. But if I divide 10 divided by 3, I get 3 integers plus a remainder of 1 over 3. So when I divide x squared minus 4 over x minus 1, I have to have a similar situation, and I have x plus 1, and the remainder is negative 3 over the divisor. Because I cannot continue. I can no longer divide 3 by x minus 1. Like here, I cannot divide 1 by 3. So now let's suppose I want to check my work. How will I check? Here I check very easily. 3 times 3 plus 1 is 10. Same thing here. This times this minus this. So when I multiply these two, I get x squared minus 1, and then minus 3, I get the numerator. So I have the same idea. The answer has to be the same. So when I have a remainder, I have to write it over what I divided by, because I can't continue. If this is 0, then I'm done. The answer is x plus 1. But this is not 0. I can't omit that answer. So this can be rewritten like this. If I omit this, they're not the same. I'm not sure I answered your question, Derek. Is this?
You did. You did. That's great. Thank you.
Thank you. So what is left from this chapter before we start reviewing it? We have left optimization. So this is a section similar to related rates, but a different topic. It's optimization. So we're going to have to work on word problems a lot. And the next one is Newton's method. So this is what is left from this chapter. On Thursday, however, I would like to review whatever you want me to review for this test. So I will create the test between now and Thursday, and we're going to work at, I'm going to give you some hints. We're going to talk about anything that I think we should review, but I also would like you to finish the homework between now and Thursday for chapter 3, so we can review whatever you need me to review. And then next week I'm hoping to finish optimization and Newton's method, and then I would like to review. I have to start chapter 5 as soon as possible. So if you don't have a lot of questions on Thursday, then I'm going to make progress with chapter 4. We need to review, because I still need, oh no, there are only 4 sections left. I need to review, I need to finish chapter 5. Chapter 5 has 5 sections, and all very important. And also one section from chapter 4 is moved with chapter 5. So, yes. Any questions? What would you like me to continue with? You want to pick another problem? You want to look at more L'Hopital's rule? You want to choose? We do not cover section 4.6. We use the graphing calculator all the time. So 4.6 is something that you can just browse through. We have 4.7 optimization, and we have 4.8 Newton's method, which is extremely useful and very easy, I would say. And 4.9 is connected to chapter 5. So we have, after this, we have 6 more sections to go. Not sure what happened to these pages here. Okay, so ready? Would you like another L'Hopital's rule?
Can we do another one of the slant asymptote ones?
Yes. So you would like to just determine the slant asymptote?
Yeah.
Okay, so let's determine the slant, and let me show you where they are. So these problems are on page 318. Find the equation of the slant asymptote. Do not sketch the curve. So any of these, 61, 62, 63, 64, they all have slant asymptotes. Also, 65 through 70, they all have slant asymptotes. Let me see. Now these. Okay. So a slant asymptote is specific for rational functions. These are not rational functions. In guidelines D, find the equation of the slant asymptote. 65 to 70, these are not rational functions. Okay, so would you like to choose, or I will?
62.
62, very good. 62 has x squared plus 2x in the denominator. We will not be able to use synthetic division. We can only use long division. So 62, and this is from page 318. We're asked just to find the slant asymptote, and that is 2x cubed plus x squared plus x plus 3, and the denominator x squared plus 2x. I'm going to put this away. Okay, so because of the denominator, we can only use long division. So let's take a look. The degree at the top is 3, degree 3, degree 2, degree 1, degree 0, no missing term. So I write 2x cubed plus x squared plus x plus 3, descending order. If there are missing terms here, I cannot do anything, but only here. I leave space for those. Okay, so I am asking myself, x squared times what? Obviously, the quotient has to be a line. X squared times what is 2x cubed, and that is 2x, and I go and distribute. 2x times x squared is 2x cubed. I have to subtract. 2x times 2x is 4x squared. I have to subtract. Perform the operations I see, and I get negative 3 x squared, and then plus x. So I bring down the next in line. X squared times what is negative 3x squared? I have negative 3. Negative 3 times x squared is negative 3x squared. I change the sign. Negative 3 times 2x is negative 6x, and I change the sign. 7x and plus 3, and this is it. Why? X squared doesn't go into 7x. So the function that initially was 2x cubed plus x squared plus x plus 3 divided by x squared plus 2x is now quotient plus remainder over the divisor. And only this is what we are interested in, because all this quantity will approach 0 at infinity, right? So y equals 2x minus 3 is the slant asymptote. Because the degree is 3 in the numerator and 2 in the denominator, the difference is 1. That's why we get a quotient with degree 1. And that is the slant asymptote.